Okay, class, welcome back. We're going to now start working in Chapter 13, Section 1, Exponents. And what we're going to be doing is learning about exponents and then multiplying and dividing common bases. So, just as a review, when we see something like b raised to the n, that just means that we're multiplying b times itself n times. So for example, if you write 3 raised to the 7th power like this, that just means multiply 3 times itself 7 times, and you get a result. And the language that we use here is whatever the base is, that right there, that number 3 is your base, and then the number on top here is called your exponent, which is why this section is called Exponents. So that's your exponent. And the way that we say something like that, where your base is 3 and your exponent 7, is we say 3 raised to 7, or we could say to the 7th power, or just 7th. So that's the language that we use. Sometimes you'll see things like, let's say 4 raised to the 2. A lot of times we say that, we will say that 4 squared. That's a very common one. And then if you did something like 4 to the 3rd power, sometimes instead of saying 4 to the 3, we say something like 4 cubed. But after you get past squared and cubed, you just say the number. So like 4 to the 5th, or you could say 4 to the 10th, or 4 to the 17th. Okay, so we're going to practice writing some exponents down here. So we have the number 9 that's being multiplied times m, multiplied times itself 4 times. So we're just going to write m to the 4th. Here we have negative 13, and then that's being multiplied by a, being multiplied twice, so a squared, and then b 3 times, so b cubed. So this is just a condensed notation, a short way of writing this, because it would suck to have to write all this out, each one of those a's and each one of those b's. So we just have a condensed way of writing it. Okay, the next example, we have x plus 3, and remember this multiplication between these times x plus 3 times x plus 3 times x plus 3 times x plus 3. We have 1, 2, 3, 4, 5 of them. So we could just write x plus 3 raised to the 5th. And that means the same thing. All right, next one, 4, and then we're going to have w 1, 2, 3, 4, 5, 6, 7 times, so w to the 7th, and then divided by, looks like we're missing a parenthesis here. There should be a parenthesis right there. We have y minus 7 times itself, so that's y minus 7 and then squared. Okay, let's continue. So if we go and we want to multiply two exponents with common bases, okay, common bases mean these both have x, then how can we put these together? So think about what this actually means. This means x times x times x times x, that's x to the 4th, times x times x times x times x times x. Now we don't need to do this each time. I just want to illustrate how many x's we actually have here. And if you count these x's, you should have 9 of them, which you would have gotten had you just added these two together. So our answer would be x to the 9th. So whenever we want to multiply common bases together, all we do is, so if you have a common base, that's very important, they have to have a common base, so they both, in this case, they both had x as the base. If common base, you just add the exponents, if you're multiplying, okay, which we were doing here. Okay, so here's the actual property. It says if you have some base raised to the m times, very important, times, not plus or minus, times the same base to a different number, then you're just going to keep the base and add the two numbers together. So let's do some examples. So in this problem, notice we both have the same base y. So we look at the exponents 6 and 2 and we add those together. So we should just get y, 6 plus 2 is 8. Okay, next problem, we both have the same base, 11, 11, and the exponents 3 and 7. We're just going to add those up. So we should have 11 raised to the 3 plus 7 is 10. Okay, in the next problem, we have the same base, 4/9, and we are raising 1 to the 8th and 1 to the 5th. So we're just going to write our common base, 4/9. We're going to add the exponents. 8 plus 5 is 13. Okay, these next few, same base, 3, and we add up and we get 18. Okay, this is a little tricky on this next one. Remember, that's p to the 1. If you just see the letter p there, there's really a power there. It's 1. So if you don't write the power, just understood that it's 1. These all have the same base, p. So we're just going to add the exponents. 4 plus 1 is 5, plus 2 is 7, plus 2 is 16. So we add those all up, we get p to the 16th power. Okay, next problem, we have 1 over n. That's a weird base, but that's what it is. And we add up these two exponents, so we just get 13. Okay, so you can see when we multiply common bases, we just add up the exponents. What happens if we divide common bases? So to show you this, let's take a look at this expression over here. X to the 6th means we have 6 x's being multiplied on top. 4, 5, 6, and then on the bottom we have 4 x's, 1, 2, 3, 4, and then what happens is we start getting some cancellation. So like this x and this x go away, this x and this x go away, this x and this x go away, this x and this x go away. Those all turn into 1s, right? Because x over x is 1, x over x is 1, so all of those are 1. So at the end of all of this, oops, end of all of that, all we're left with are these two x's right here, which is just x squared. So how else could we have gotten an answer where our exponent was 2 if we started with 6 on top and 4 on the bottom? Well, we could have just subtracted them. If we do 6 and we take away 4, that would have given us that exponent of 2. So when it comes to division of common bases, we have another formula. So it says if we have the same base, okay, and we divide, we are going to subtract the exponents, and it will always be the top one, okay, the top one, m, minus the bottom one. Don't do it the other way around, okay? So for this example, excuse me, hold on. So for this next example, we have the same base, y. We have exponent of 9 and 4, and we're dividing, so we're going to subtract. So we're going to do y to the 9 minus 4, which is y to the 5th. That's our answer. Next one, we have the same base, 2, 2. We are dividing these, 15 and 9. So our answer is going to be 2, and then raised to the 15 minus 9, which is 2 to the 6th. Okay, on the next one's a little tricky because we need to first put these two together. So remember, that's k to the 1 times k to the 7, that's k to the 8th, and then over k to the 4th. They both have the same base. We are going to be dividing, and we have these two exponents, so we're going to subtract those. So this should be equal to k to the 8 minus 4, it should just be 4. All right, here's some group work. This one's going to be d, I'll give you a second here. D to the 7th, because you're subtracting. 20 take away 13 is 7. Here, this is a little tricky. 9 to the 1st power on the bottom, even though I don't write it. So this is going to be 9 to the 8 minus 1 is 7. On the next one, what we want to do first is put together on the bottom, put these two together. We're multiplying those. They have the same base, so we add the exponents, q to the 5. And now we use the division to do subtraction. So 6 minus 5 is 1. So our answer here is just q. All right. So let's try simplifying some more complicated expressions. So when we read this, what we need to understand is this is 5 times x to the 6th times 4 times x to the 7. So what I'm going to do is put the 5 and 4 together to get me 20. And then x to the 6th times x to the 7th, I add the exponents, and that should give me x to the 13th, because they have the same base x, right? Okay, let's look at this next one. We have negative 6 over 11 m. Oh, I've got to pause this real quick. Okay, I think I'm back, hopefully. Okay, so we had 16m to the 10th n cubed, and then times 33m to the 4th times n. All right, so let's take care of the numbers first. We're going to take negative 6 over 11 and multiply that times 33, which is really 33 over 1. And that will allow us to reduce this fraction because 11 goes into 11 once and 11 goes in 33 three times. Okay, so we'll handle that in a moment. Now let's take care of our m's. We have m to the 10th and m to the 4th. We're multiplying those, so we add the exponents. So m to the 14th. Then we have n to the 3rd and n to the 1st power. So when we add those exponents, we get n to the 4th. And so our final answer here, we multiply straight across. Negative 6 times 3 is negative 18 over 1. So negative 18, m to the 14th, n to the 4th. There we go. Okay, the next problem we have division. So we have to be a little careful here. We're going to do 45 and divide that by 9. Luckily for us, that's a nice number, 5. And then when we do the a's, a to the 7th over a squared, we're going to subtract exponents. So 7 take away 2 is 5. And then we do the b's, those have a common base. B to the 4 over b to the 3rd, you subtract. 4 minus 3 is 1, so we just get b. And that's it. Okay. So these are ones you can work through. Give you a little bit of time there. And okay, so what do we got here? So here we put the numbers together first. So negative 10 times 2 is negative 20, and then times 5, that should give you negative 100. And then let's do our y's. We have y to the 11th, and then we have y, and then we have y to the 3rd. So remember that's y to the 1st power here. So add all those exponents up, 12, 15, you should get y to the 15th here. All right, next one. Let's see, we got p here, p here, p here. I'm trying to find all the ones with common bases. Okay, so those are my p's. R's, I have an r here. And then q's, I've got a q here and a q here. So taking care of the p's first, adding all the exponents, we should get p to the 14th. R, remember that's r to the 1st power, so add that to 5, we get 6. And then the q's, we're going to be 6 plus 3 is 9. There we go. Okay, last one. This negative 9 over 8 cannot be reduced, so I'm going to put negative 9 over 8. I'm just going to leave it. And then let's take care of these c's. C to the 12th over c to the 5th. We have division, so we subtract. That should give us c to the 7th. And then we take care of the d's. D to the 8th over d squared. Subtract, we should get d to the 6th. And notice how I just put this fraction out front. That is perfectly fine. We're multiplying that fraction times c to the 7th times d to the 6th. All right, that should do it for this section.